Okay, hello everyone. We are continuing on where we left off. We are still in section 1.2. We are studying different ways to graphically display numerical data. And this is just kind of a review of where we left off. So it's one of the most important things to remember when you're asked to compare, okay, keyword here, you're comparing two distributions, is to use comparative language, okay? Things like, oh, this one has a larger spread than this distribution, and then state what those spreads are. Or the center of this distribution is much smaller than the center of this distribution. What they absolutely do not want you to do on the AP test is to list two columns and list the CUS, center, unusual value, shape, and spread for one variable and one distribution, and then over in a separate column list those same things. That's when you're not really comparing them. You're just listing the facts about each one. They want you to address and compare the centers of each, and then for each of those aspects, okay? And then the other thing that people often forget, and you get docked on the rubric for this on the AP test, is they want you to answer in context. So make sure that you're mentioning what the variable is representing. If you're talking about number of people per household, make sure that's mentioned somewhere in your description, not just a number that doesn't have any label to it, okay? So the other type of graphical display that we're going to look at, I know we looked at a dot plot, which is, we said, was the simplest type here in the previous video, is we're going to look at something called a stem plot. It's also sometimes referred to as a stem and leaf plot. Okay, and stem plots basically give us a quick picture of the distribution, but here's the advantage of a stem plot over a dot plot, is it preserves the actual numerical values. Okay, so we know in a dot plot, I suppose you could kind of see what the numbers are because they're above the dots there. Above how you have the number line labeled. But we're going to talk about a stem and leaf plot, and you'll see what I mean with it kind of preserves the actual, or at least it uses the actual numerical value instead of a dot. Maybe I'll say it that way. Okay, so again, there's some steps here that talk about how to properly make a stem plot or a stem and leaf plot, and I'm going to demonstrate those steps for you with this example here. It says, these data represent the responses of 20 female AP statistics students to the question, how many pairs of shoes do you have? And it's asking us to construct a stem plot. Okay, so here we have the 20 answers for these female AP stats students, and it says here to separate each observation into a stem and a leaf. Now here's the key. The leaf is always the final digit, okay? So I'm going to go ahead and label here stem. You're going to separate this with a vertical bar, and then I'm going to call this the leaves. Okay. Now, when you make this graph, you do not have to have these labels, stem and leaves, up above there. I'm just doing that on this example so that you can see which part is called which thing. Okay. So the next thing you'll want to identify is you will want to identify in your data set what is the largest answer, and as you skim through this, I think you'll see 57 was the largest answer. Then you also want to identify the smallest answer. It looks like that was 13. Okay, now keep in mind, it says here the stem is all but the final digit. Okay, so if these were 3-digit numbers, the stems would be the hundreds place and the tens place. The leaf would be the ones place. If these were, I'm going to just give you an example here. If these were decimals and they were things like this, okay, then the tenths place would be the leaf, and the tens and ones places would be the stems. Okay, so the stem is all but the final digit, and the final digit is the leaf. Okay. All right, so let's go ahead and see if we can do this here. It appears that the smallest stem is the tens place. That's and then it goes, there's some 20s, 30s, 40s, and 50s. Okay, and then you're going to put these in order. So we said that 13 was the smallest, so I'm just going to kind of go through here. I see this 13 that I circled, here's another one, and here's another one. So there were 3 13s, so I'm going to write the number 3 times in a row, and the idea is here that this 1 goes with that, and then it's showing me another 13 and yet another 13 there. Okay, now I do think that there also is a 15. Okay, that's right here. So I'm going to put that right after the 3. And then there also is a 19. I'm going to put that there. So you just kind of stack these numbers here. You do want to kind of make them nicely spaced apart, because here's what's going to happen. When we get down to the stem for the 20s, okay, it looks like, and I'm not going to circle all of them, I think there was a 22, there were 2 23s, there's a 24, and then 2 26s. You want to make sure that you're lining these up nicely in these columns, and I'll show you why here in just a moment, but I'm going to go ahead and fill in the rest of these here. Hopefully you can see where I'm getting these from. One girl answered 30, 31, 34, and 38. There was one student who answered 49, 2 50s, a 51, and then the 57. Okay, by the way, if no one answered in the 40s, you still have to put a 4 here for a stem. You would just have no leaf over here. Okay, so once you start your stem, whatever the smallest and the largest is, you have to include all the numbers in between. Okay, now here's the advantage of this. If you were to turn your paper sideways, it almost has a dot plot feel to it, where you could turn your paper sideways and kind of draw that curve over top and sort of get a sense that maybe it's kind of roughly symmetrical there. Okay, now here's the other important thing. We had said here, you always have to provide a key that explains in context what the stems and the leaves represent. Okay, now here's how you would provide the key. I'm going to just label it key. You pick one value from your data set. Okay, so I'm just going to go with 49. Okay, and so you show for line 9, and then you say represents a female AP Stats student who owns 49 pairs of shoes. Okay, shows how to read it. Okay, you could pick one response. You could have put 1/13. You pick any of these answers and just use that as a demonstration in the key. Okay, you will get docked points if you do not include a key if an AP Stats test question asks you to create a stem and leaf plot. Okay, now when your data values though are sort of bunched up, and I'll explain what I mean by that, but if they're really bunched up, you can get a better picture of the distribution if you do something called splitting the stems. Okay, and I have an example of what I mean by this right here. Okay, splitting the stems generally is when maybe, remember these are the stems, these are the leaves. You'll notice there are 2 stems for each, and I just made this data set up. This doesn't have anything to do with the previous problem in the shoes here. Okay, but if you start to feel like, wow, there's a lot of numbers, and you know these are getting really big and they're long out here, you can split it where the first stem gets all the leaves that are 0 through 4, and the second stem gets all the leaves that are 5 through 9. So if you see here, I included all the leaves, so this would be anything from 10 to 14, and this is everything from 15 to 19. This would include 20 up to 24 if there was a value for that, and this would go 25 to 29, okay? That's just kind of splitting the stems. It's another way that you might see a stem and leaf plot. Again, this should have, some type of key provided. I'm just going to say that equals 11. I don't have any context here because I just made those numbers up. Okay. Now, sometimes there are 2 distributions for the exact same quantitative variable that you're wanting to compare, and you can do this by what's called a back-to-back stem plot. Okay, so again, we don't have, I guess we're just going to assume that these values, since these are the same values as before, that the males were then asked in this AP Stats class how many pairs of shoes they owned. Okay, you can see it looks like for the most part these are smaller numbers, so that kind of makes logical sense here that they might not have as many shoes as what the girls would have. Okay, now how can you do what's called a back-to-back stem plot? Okay, well you're gonna go ahead and put your stems down the middle. Okay, so the reason I'm including 0 now as a stem and I didn't before is because there are some single-digit answers here to the males. And I need to include the stem is representing my tens place. So on something like 7, 0 would be the stem. Okay, now I'm going to put a line here, but I'm also going to put a line here. This is for my back-to-back stem plot. Now, it would be important that you label, you don't have to put the word stem up here. I'm going to go ahead and erase that actually. Okay, but you should identify like male and then female. Okay, now you'll see what my note is up here. It says, note, the smaller numbers stay close to the stem. Okay, that means they're staying like close to that vertical bar here. Okay, now the female data, I know we just made this on the other page, but now it's a little weird because I'm putting the female data over here on the left side. So the smallest answer was 13, so I'm putting the 3 closest to the stem. Remember, there were 3 people who answered this. So the part that feels weird about this is you're working from like right to left, and it's getting bigger as you go right to left. Okay, so this would be how I would fill these in. It's a little easier to read a stem and leaf plot if your leaves are on the right side, okay, which is what I'll do for the male data here. And I think you see where I'm getting these numbers from, and so I'm not going to talk through all these, but you get the idea that, you know, there were 4 guys who answered that they had 7 pairs of shoes. The important thing is, you'll notice I'm trying to keep these lined up nice and vertically so that if you were to turn it to the other side, you got an idea of what the frequencies are here, okay? Let's see, there's a 2, there's a 5, there's an 8, and I'm leaving these completely empty because no guys were in the 40s or 50s. Okay, I do need to provide a key, so I'm going to go ahead and just jot down over here key. And I really should provide 2 keys because with a back-to-back, you know, you are kind of looking at things a little bit in reverse when you go to the left side. So I'm going to do 2/2 for... That's probably a bad example because that exists on both of them. But let me go ahead and do 1/0 represents male AP Stats student owning 10 shoes. Okay, and then, now here's where you gotta be careful. So I picked this for the males. Now when you write this down, you write it how it looks there, okay? But that represents 49 pairs of shoes for a female student, okay? Okay, so, you know, I talked about how you can kind of draw these lines over top like that to sort of get a sense of the shape of the distribution. Okay, and we talked about right skewed, we talked about left skewed, but there's another term that you're going to see quite frequently. We know, I'm pretty sure that you guys have been introduced in elementary statistics and other courses that mode is the number that occurs most often. Okay, so when you hear the phrase unimodal, una means 1, bimodal, that means 2, okay, and uniform, that word means same, okay? So when we talk about a shape being unimodal, that means that it has 1 peak to it, okay? So technically, roughly symmetric would be unimodal. Skewed to the right would also be unimodal, because we're just talking about like how many peaks are there at the top. Okay, bimodal would be something, and they don't have to, the peaks don't have to be exactly the same height, but you know, a lot of times they are both, you know, kind of competing for the most frequent value. That's an example of like a bimodal graph. And then how a uniform graph would look, it's going to be flat and constant, okay? So there's going to be no hills, or valleys, or essentially look like there aren't any, okay? Kind of just flat, straight across the top. It'd be like a dot plot where everything kind of just showed up about the same amount. That's what we call uniform, okay? All right, and then down here, what is the most important thing to remember when you are making a stem plot? And that is, don't forget to provide a key. Okay, we definitely want to provide a key there. Okay, so let's take a look. We've been talking about comparing distributions. This is a great example. It talks about Brian and Jessica. They've decided to move. They're considering these 7 different cities. They're labeled A through F. You can see down here along the side. Did a nice job here of labeling the context of what these letters are representing. It says the dot plots below show the daily high temperatures in June, July, and August for each of these cities. Okay, so again, these are daily high temperatures in the summer. Help them pick a city by answering the questions below. Okay, so I'm going to go ahead and scroll down so that we can see. Also, nice job here. They've labeled with numbers and they've identified in context what those numbers are referring to. That's the daily high temps in June, July, and August. Okay, so here's our first question. The first question is, what is the most important difference between cities A, B, and C? Okay. So this is what you want to be thinking when we're comparing these things. You want to be thinking of differences that you see in any of these things. A difference in the center, like where the middle temperature would be. A difference maybe in something including any unusual values. That's what we refer to as outliers. Okay, maybe there's a difference in the shape of the distribution. Proximately symmetrical versus maybe right or left skewed. And then finally, the spread. Is it bunched up and there's not a lot of variation? Or is it really stretched out and there's a big difference between what these temperatures could be? So the most important difference between cities A, B, and C, and I'll be honest, these look like they span about the same distance. Okay, I mean, they have different, they range differently from a low and a high temperature, but that's really referring to where the center is. Like if I were to pinpoint, okay, where's the center for this? And I'm just roughly, we would say maybe here, here, and here. That looks like that's the biggest difference between these 3 cities. So I'm going to say here that the average or typical high temp is different in each city, okay, referring to A, B, and C there. Okay, hopefully that makes sense to you here. Okay, let me clear this off and we'll take a look at question number 2. Now, what is the most important difference between cities C and D? Okay, so now we're looking at these 2. Okay, again, think back to our CUS acronym. What does it look like is the most important difference for this? Okay. Now, if I look at the center for city C, I might say here, the center for city D, maybe somewhere here. They're not that far off. So I don't know if it's really the center so much as it kind of feels like the spread. City C isn't varying as much as city D. There's some months where it gets down below 60 as the high, and somewhere it's over 100 as the high. Okay, so I would say for number 2, we could say either the range, you could use the word variation, or you could say the word spread is, now notice how I'm using comparative language here, is much larger. Okay, that's a great phrase to use to compare for city D than city C. Okay, question 3. What are 2 important differences between cities D and E? Okay, so let me just get this cleared off here real quick. We are looking at cities D and E. It's asking us for 2 important differences. Okay, 2 important differences. Well, as you look at D, it kind of feels like this is almost somewhat uniform. Whereas in C, I would maybe refer to that as being roughly symmetric. Okay, so I might describe that as one important difference. I'm going to say city D's distribution is more uniform, and city C is roughly symmetric. Okay, and then another difference here, and a lot of times I will say this, when there are outliers, a lot of times those outliers are excluded when you're referring to what your spread is, okay? Like, for example, if we took out the outlier in those two outliers in city E, the majority of the days span a very small degree range here, okay? Whereas I can't really say that for city D, okay? So we might just respond something like this. City C has much less variable temps than city D, and then I'm just going to make a note, excluding the outliers. Okay, and then finally, what is the most important difference between cities C, F, and G, it says here. C, F, and G. Okay, let's just focus on those. C, F, and G. Most important difference between these. Well, this really feels like, oh, it's probably the shape, okay? Okay, so we can just remark here that the shape of the distributions. Okay, and then I'm going to be specific and say city C is roughly symmetric, city F is skewed right, and city G is skewed left. Okay, there is an assignment here. Okay, these problems at this point you should be able to do now. I encourage you to do that rather than wait. It is best to work through these as